Okay, so we continue with this TF IDF. Okay, so in the previous subchapter, the term frequency, we use the frequency as the weightage of each of the keyword that we have in the document to quantify the ranking, right? Tapi we not yet up to that. We are looking at representing the document in the term document matrix concept. Okay, so in here we introduce another concept called TF IDF weight. There is a reason why we introduced this one, because the term frequency that we have, this one alone, is not enough. So they introduced this inverse document frequency in order to eliminate document that, no, to eliminate keyword that exists in all of the document. Because if a specific keyword that exists in all the document, that means we cannot use the keyword to determine whether the document is important with respect to the keyword, because the keyword exists in all of the document. So we do not want to have this keyword. So we eliminate them by putting the value 0 here. Okay. Okay. So we go back to this term frequency, and we introduce inverse document frequency, and we look at the foundation of the most popular term weighting scheme in IR. Okay. So now we are focusing on TF IDF. Okay. Learn is one of the person that coined the term information retrieval. So based on his assumption, the value of the weightage ij is proportional to the term frequency. So which is the degree of importance can be measured by using the weightage, which has a direct connection with the frequency here. Okay, so the more often a term occurs in the text of the document, the higher is the weight, the higher is the importance. Okay, so this is based on the observation of high frequency term are important for describing each of the document that we have. Okay, so over here they say that the term frequency is equivalent to the frequency of the keyword that exists in the document J. Okay, and they introduce this log. Okay, instead of using the frequency itself, they introduce this log value here. So instead of taking this only, they introduce log base 2 of this. There is a reason why they use log base 2. Okay, the first reason is that they want to reduce the value to a smaller number, so that any changes of the frequency, large or small, it can be absorbed by the value that we have here. For example, if the frequency of the term is 1000 or 10,000, so we compare to a document which has only 50. So if we take the differences will be larger. But if we have log and this value, the value will be smaller. Okay, so the differences is not too drastic, too large when we compare the ranking later on. So that is the first purpose. The second purpose is to know how much bit that we bit here is bits. How number of bits that we use to represent the document. Okay, for example, if that document exists 4 times, okay, and then if we have that one log 2 and 4 times the exist, this is 2. So that means that term require 2 bits to represent the importance of that term. So that's why we use the log base 2. Okay, because some people say, okay, well, why not we use the frequency only instead of this log? They say, why not use this? Why not use this frequency only? And the term frequency that introduced by Learn is using this formula, where they use the 1 plus log base 2. Okay. So the value of this is greater than 0, and otherwise it will be 0. So we use this formula. Okay. So the log expression is preferred form because it makes them directly comparable to IDF weight. So later on we will see what is the IDF here. Okay. So now let us take a look at how do we compute the TF here. Okay. So for the list of vocabulary that we have here, but this example is not perfect, because remember that in order to build this vocabulary, we remove all the term, all the stop word. This is all stop word. Is, be, or, not, am, therefore, it. This one carry no meaning. So all of these are stop word. But for the sake of simplifying the vocabulary that we have, so we assume all of them are valid term lah, valid keyword. Okay. So for each of the keyword that we have in our vocabulary, this one. Okay. So for example, this is document 1. Okay, document 1 for 2, there exists 1, 2, 3, 4. So 4 times, right? So if you look at here, so the formula is 1 plus log base 2, 4. So the value is 3. So 3 will be here. Okay. And for the do in document 3, for the do in document 3, how do we get this value? So the do in document 3 is 3 times. Okay, so we plug in the value here and we compute, we get 1.58 plus 1, 2.58. So we have this one. Okay. So this is the TF. They take the frequency of each of the term and then they plug in the value and we get the term frequency here. So that's how we get this term frequency. Term frequency for the term document metrics that we have. Okay, boleh. So your skill that you need to learn for this is how do we construct this term frequency table. Okay. Any question? Okay, now the issue that why invest document is proposed is that you look at this. This keyword B exists in all the document. That means the keyword B cannot be used to distinct the importance of the document, right? Sebab dia dalam all document itu pun semua dia exist. So that means the importance of this term B is very low. So in order for us to ignore this, we want to set this one to be 0. So how do we make this one 0? So they introduced the inverse document frequency. Okay. So the inverse document frequency is basically taking the number of document that consists the keyword I, and you have this number of document in your storage. You take the log base 2 of this formula. So for example, in just now for the IDF of, so if we are looking at IDF at the top, B, this is B. So we have log base 2 and we have 4 documents, and for NB we have 4 also, right? So log base 2 1 is equal to 0. Okay. So if we based on this, based on the term that we have, then we compute IDF here. So if you look at B, the number of documents that consists B is 4. So that's why they become 0 here. Okay. So if you go back to the formula, TF IDF is basically the multiplication of term frequency and IDF. Okay. So the full weightage now will be, this is your TF and this is your IDF. Okay. Okay, this is one of the reasons why we use log base 2, because we want to quantify the term that exists in all the document that they have. So if that keyword exists in all document, this one automatic will be 0. So that's why they use log base 2 also to capture the event in which the keyword exists in all the document. Okay. So this is what we call the TF IDF weighting scheme. So this is to eliminate keyword that exists in all document. This one is used to capture the frequency of each of the term in the document, but they use log base 2 saja. Okay, so there are 2 parts here. So when we compute the overall weightage, is basically we take the TF multiply with the IDF here. Okay, so we get this lah. So basically all this times 1, and this one is times 0.4145 and so on. So that's how we get this. So this is your final TF IDF matrix. Okay. So this one will be the foundation of the model that we will be used for document retrieval, and it is very important. Okay. Any question? Hujan sudah. Okay. Okay. Now we want to go for the ranking. Okay. This one, if you look at all this document here, the length of the document is more or less the same, which is the number of terms in each of the document are the same. Okay, let's suppose we do copy paste for this one many times inside this document. So the length of this document will be large. more compared to these three, right? So the occurrence of do will be more. So it's not fair if we say that, okay, this do exists more in this document with respect to all of these three, because this one have 4 times longer. The size of the document is longer compared to these three. Okay? So to normalize this situation, we need to take the size of the document, and then we use the size of the document to normalize the calculation for the weightage. Okay? So over here, the document size might be vary for each of the document. Okay, and this will introduce a problem because longer documents are more likely to be retrieved by a given query because that particular keyword exists many times. Okay, to compensate for this undesired effect, we divide the length of each document by its length. So this is we call normalization. Okay, document length normalization. Okay, so similar to if you perform modeling for data mining, you also have to normalize also. So similar to information retrieval, in order to compensate the effect of longer document, we perform document length normalization. So the size of the document can be measured in terms of size in bytes, number of words, vector norms. Okay? So these two can be computed based on the number of words that we have. Okay, for instance, the document length can be computed by using this. We assume that each document is represented as a vector of weightage of the keyword that we have in the vocabulary. So this is a vector. Okay, so to capture the document length, we just have to take the square of this, sum up all the value, and then take the square root. So this is the absolute value of the vector document J. Okay. So how do we do that? We need to show how we get this one. Okay, let's go back to here. Okay, these are the value that we have, right? So to capture the length of this document is basically we take the square root of 3 square plus 0.8. I represent, yes. I represent keyword, J represent document. Square plus 4. Okay. So this is the length for document D1. Okay. So if you compute this one using your calculator, so you will get this value. So to double check, you can compute on my calculator. So we have 9 plus 16 plus 0.83 So the answer is this one. Boleh. So to measure the length of this one will be 4 times 6 square root. So this is 24, square root of 24. So square root of 24 is equivalent to 4.89. Okay, so that's how we get this. Okay, so this is the length of each of the documents. So we use this one later on to compute the distance. Okay, so we keep this information. We have this, the TF IDF, and also we have the length of the document. So we keep this information for later use. Okay, so now we go to the vector model. So this is a model that introduced by Shannon. They say each document can be represented as a vector. So for that reason, we can use the cosine function in order to compute the differences between two vectors. Okay. So looking at the previous model, Boolean matching and binary weight is too limiting because we cannot perform the ranking. Okay, so for that reason, the vector model proposes a framework in which we can produce the ranking based on partial matching. Okay, so this can be accomplished by using the TF IDF that we have, and this can be used to measure or quantify the degree of similarity between the query and each of the document. And for that, we can perform the ranking. Okay. So if we assume that in the vector model, each weight associated with P, Ki, and Dj, where I refer to keyword I, J refer to document J. So we can represent each of the document like this, and the query like this, which is the vector representation of the weightage of keyword in each of the document that we have. Okay, so this is in the vector model. So they said, okay, the degree of similarity can be computed using the cosine function here, where we want to know how much degree that we have for these two vectors. So the closer they are, the smaller is the degree, the more similar they are. Okay, so for the cosine function, we have this formula in which we multiply the vector of the document with the vector of the query divided by the magnitude of document J and the query. Okay, so this is the formula to look. So basically, if we multiply these two vectors, we are multiplying the same weight, the same keyword. We multiply the weightage of the same keyword for document J and the query. And this is just basically trying to look at the, what we call it? Remember this formula? This one is with respect to the query. So this is basically the length of the document. This is the length of the query. Okay. So if we look at the formula here, the TF IDF, the weightage for keyword I in Q is basically the same here, but this one is in the query itself, but this one is in the document J. So this is the same formula that we have for the TF IDF. but this one is with respect to the query lah. Okay. Okay, if we go to the example here, suppose that we have a query to do. Okay, to do. So the query, the vector for the query will be, because we have the smaller the angle between, yes, because the smaller is the degree, means they are more similar, right? Because the vector will be closer to each other. So the higher is the ranking, because the ranking is defined based on the similarity of the document. So if the theta, the cosine theta give you smaller number, they will give you higher ranking. Okay. Okay. So for example, like this, we have. Okay, since we are looking at the query here, and also we want to look at what is the differences between the query and document one, we look at the document one here. Okay. So when we look at the document one here, our vector consists of this only. Okay, so we have 3 point at 3 and 4. Okay, so for that reason, we will construct similar vector for the query. So the 2 is here, and do is for this one, and this is the is. Since we do not have is, so this is 0. So when we compute the frequency is 1, this is also 1, because in the query we have one time only, and the IDF here is 1, and the IDF for this one is 0.415. Okay, so this is the vector for the query for to do, for the keyword to do here. So we have the vector for the query, we have the vector for the document, then we can compute the calculation here. Okay, so for this one, we multiply this with this, and then this with that one, and this one with this. Then we get this one. Okay, so if you look at the formula here, what is this one? This is the length of document I, right? Document 1. I go back to the formula here. So this is the length of the document, right? This is the length of the query, right? But in this example, this is only the length of the document. We're supposed to have the length of the query vector, right? But all of them have the same, so we can ignore this. Of course, the number will be different, but the ranking will be correct also. We multiply juga nih semua. Since all of them are can be considered as constant, we don't have to compute that one. But the length of the document depends on individual document that we have. So that's why this is maintained. Okay, so we know how to compute di atas nih, we know how to compute di bawah nih, then we can perform the ranking here. Okay, any question? Okay, so this one is the detailed calculation for the, this one is for the this one is if we include the length of the query. Okay, this is the length of the query. So it will be different, but the ranking is still the same. Okay, any question? Okay, so the advantage of using the vector is that the term weighting improves quality of answer set because we allow for partial matching. Okay, if you compare with the Boolean model, they do not allow for partial matching. So the vector model, they allow this one. Okay, and since in the vector model we represent each document and also each of the query as a vector, then we can use the cosine ranking formula to perform the ranking. Okay, so this is very good because now we can quantify them based on the value of the weightage of the keyword that we have in our set of document. And we can also use the document length normalization in order to reduce the bias of having two big size of document. But the disadvantage is that we have, because in the document, we have sentence, right? And if we convert them into term document matrix, then the sequence of the term is lost already. Okay, so how do we capture the sequence? Then we can use the term correlation, but we are using bigger n-gram. This is the n-gram refer to how many word you capture. The example that we've gone through today is 1 gram only. We can have 2 gram in which we capture 2 words at the same time. Or we can use 3 gram. Okay. So by having 2 or 3 gram, then we can capture the dependence of each of the term with respect to each other using the some metrics that we have, or we could use the term correlation. Okay. Okay. Any question? Okay. Yes. Raja. Yeah. Any question? Okay. I have a small exercise here. Okay, so I let you produce TF IDF for this one, and then based on this view, we will have the ranking. Okay. So now is 11:30. Let me stop this one first. So what I want you to do is construct the TF IDF and tell me the ranking of the document based on the query that we have. So you do it manually lah. So please also remove the stopword and also perform the stemming if you able to identify them.